Okay, so if you would open up your notes packet to the radical equations section, you're going to look for number 7, and that's in the word problem section. Okay, so let's read number 7. So it says the speed of a tidal wave, s. So speed is s, okay? So the speed of a tidal wave, which is measured in hundreds of miles per hour, can be modeled by this equation. So remember, this S stands for speed. And then it also says where T represents the time from its origin in hours. So T is time and S is the speed. So this would be my speed. These T's represent time. Okay? All right, now I know I keep repeating myself, but that's kind of important. So if I have S equals, I'm just going to start with this equation, radical T minus 2T plus 6. And let's look at what they're asking us to find. So it says algebraically, so that means we need to show work, algebraically determine the time. So they want you to find the actual time. They want you to solve for T when S is 0. So they just gave you what S is equal to. So all we have to do is go over to that equation, and where you see an S, you're going to replace that with 0. Okay, now we've been doing this. So if you recall from Tuesday, we have to, when we have a radical equation, we want to isolate that radical. So I see that I have a radical T on the right-hand side of the equal sign, so I'm going to let that be, and then what I'm actually going to do is I'm going to move the other stuff over to the other side to isolate that radical. So I'm going to add 2T here, and I'm going to add 2T here. Okay, I'm also going to subtract 6 here, and subtract 6 there. So those guys are going to cancel out, and on the left side I'm going to have 2T minus 6, and on the right side, I have radical T. Okay, so I just isolated that radical. Now remember the next step, and you can always go back and you can look at this page that it says radical equations on it. And at the top, the first thing it says that you need to do is isolate the radical. And then if you have a square root, which we do, then we are going to square both sides. Okay, because when we want to get rid of a radical, we do its opposite operation, which would be squaring. And what that's going to do is get rid of that radical. It's going to cancel it out. But what you do to one side, remember you have to do to the other. Now you just want to be a little careful here because I've got a radical. I have got a binomial squared. Okay, anytime you have a plus or minus between two terms here, that's considered a binomial. And when we square that binomial, remember what that means. That means that you have to write that value, 2t minus 6, 2 times, and you are going to have to double distribute that. Okay, and then on the right side, we're just going to have t because the radical canceled out. Okay, so when we double distribute, we're going to get 4t squared minus 12t minus 12t plus 36 equals t. So let's simplify a little bit. So I have 4t squared minus 24t plus 36 equals t. And then I'm going to move that t over. Okay, because I do have a quadratic. I have a t squared term, so I know that I'm going to end up having to factor this. So I'm going to bring down my 4t squared minus 25t plus 36, and that equals 0. All right, now we're going to have to factor this, but please be careful because this lead coefficient is not a 1, so we're going to have to rainbow that. Okay, so let me try that in a different color so we can see it a little bit better. Stands out a little bit more. So when I rainbow this and I multiply those two numbers, I'm just going to squeeze it in over here. That is 144. It's kind of a large number. And we have to add to negative 25. So if I were you, I would go to your calculator, go to y equals, and type in 144 divided by x, and go to your table. Okay? And look for two numbers that multiply to 144 that could subtract to 25. Okay? So that is going to be a negative 16t and also a negative 9t. And we drop down the last term and set that equal to 0. All right, just as a reminder, make sure that you're writing this down in your notes. So then when we group here, we can take a 4t out of the first grouping, and that's going to leave us with t minus 4. And then out of the second grouping, I'm going to take out a negative 9, and that's also going to leave us with t minus 4. That's a minus sign there. Minus. There we go. Okay. All right, so now let's put our GCFs together. So that's 4t minus 9. And then in the other set of parentheses, I'm going to have t minus 4. Okay, so again, it says algebraically determine the time when s is equal to 0. Okay, so I'm going to do my little t-chart here. And I'm going to set 4t minus 9 equal to 0. So I know that I can add that 9 over, so that's going to be 4t equals 9. And then I know I can divide by 4, so t will equal 9/4. And then on the right-hand side, I have t minus 4, set that equal to 0. And I know I can add that 4 over, so that will be t is equal to 4. Okay, so now just remember that whenever you're doing a radical equation, you need to check both of your answers. So this t equals 9/4, that's a t value, so that's got to go in here, and that's got to go in here. And essentially what we want to do is we want to see if when we plug that in, if we get 0. Because remember, we put s, we replaced s with 0. So we want to see if we plug in our 9/4 here, will I end up getting 0? Now, if you look down here at what I just took a picture of my calculator, so you can see that I stored 9/4 in as x, and then I just typed in the right side of the equation. And when I did that, I don't get 0. So remember, that means that we're going to reject that value. Okay? And then you would do the same thing again with t equals 4, and you would find out that that will actually, in fact, give you 0. Okay, so our final answer is t equals 4, and we should write hours because that's the unit of time that we're referring to. Okay, now for the second part, they're just asking how much faster was the tidal wave traveling after 1 hour than 3 hours to the nearest mile per hour. So what we're doing is we're comparing how fast is the tidal wave going after 1 hour versus how fast is that tidal wave going after 3 hours. Now remember that hours stand for time. So basically right here they're saying how fast is that tidal wave going at time 1. And then this one is saying how fast is that tidal wave going at time 3. So basically you're going to take this equation and we're going to plug in 1 for t. So let's do that. Radical, time is 1, minus 2 times, here we go, time is 1, plus 6. And we're just going to work that out. So the square root of 1 is 1, minus 2, plus 6, and that equals 5. Okay, so that's 500 miles per hour, because if you go back and you read the very original question, it says the speed of a tidal wave s in hundreds of miles per hour. Okay, so this is, even though this is 5, okay, it is in hundreds, so that's really 500 miles per hour. All right, now let's do the same thing. Let's use the same equation, but now we're going to plug in 3, and we're going to compare, and we're going to see what we get. So radical 3 minus 2 times 3 plus 6. Now, radical 3 off the top of my head, I really don't know what that is, but it really doesn't matter because you have a calculator. Okay, so you're going to plug that in, And then you're going to end up getting, let me see, hold on one second. If I put that into my calculator, I'm going to get 1.7320. Now remember, that's in hundreds. So I would have to take this answer right here and I'd have to multiply that by 100. Okay, just like here, we had an answer of 5, but when I multiplied 5 by 100, I got 500. So I have 1 point blah, blah, blah here. I need to multiply that by 100 as well. And when I do that, that's roughly 173.20 blah, blah, blah miles per hour. So you can see that the tidal wave is going faster at time 1. Now, let's read the question because it says how much faster. So what that wants you to do then is subtract your two answers. Okay, so it wants you to subtract that 500 minus that 173, and I'm looking at the digits in my calculator, 0.2050. And if I subtract those two, that's 326.79. And it says to the nearest mile per hour. So that would be 327 miles per hour. Okay, when it says to the nearest mile per hour, they want to the ones place. Okay, so for number 8, I would hope that you have read it. If you haven't, just pause me and read it over. Okay, so a couple of things that I sort of underline. And it says here we've got some kind of a wind scale. Okay, similar to like a Richter scale. You know, when you have an earthquake, right? There's a 5.0 on the Richter scale. So we have a Beaufort wind scale. So based on observations of the effects of the wind. Now it says here, Beaufort numbers B, so these are all the Beaufort numbers, are determined, so the way we get these numbers are determined by this equation here. And they're telling you S stands for the speed of wind. So this value right here stands for speed. And this is your Beaufort number. Okay, so speed of the wind, and this is your Beaufort number. Okay, and B is rounded to the nearest integer from 0, and you can see that, all the way down to 12. Okay, so they want you to use this table and classify the force of wind at a speed of 30 miles per hour. Okay, so look, they're giving you speed, so they're giving you S, and all they want you to do is take this equation and plug in 30. Okay, so we can do that. That's pretty easy, right? So we're just going to do B equals 1.69. Take the square root, and we're going to put in 30 here, plus 4.45, and then we're going to subtract 3.49. And you can put this all in your calculator and just work that out. Okay, so when I do that, I end up with 6.4293. And let's read this. It says, using the table, classify the force of wind at a speed of 30 miles per hour. Justify your answer. Now, if you look at this, though, we have a decimal value. And remember, it says that the Beaufort numbers are rounded to the nearest integer. So we're going to round this to the nearest integer, which 6.4 would round to 6. And then they want you to classify that. And if you look there, your classification would be that it would be a steady breeze because you have a 6. Okay, so again, I would please make sure that you read the question. If you didn't, just pause me and read it. Okay, and make sure you're taking notes in your packet. So if you read this question, it says in 1946 they adjusted the scale because I guess they were getting some strong hurricanes. And so basically what they're saying here is a strong hurricane received a B value, a Beaufort value of 15. So they're telling you that this is 15. Algebraically, so we're going to put 15 in here, algebraically determine the value of s. So we're trying to find s, and we're going to be rounding it to the nearest mile per hour. Okay, so we're just going to take that equation, and we're going to put in a 15 here. So 15 equals 1.69 times the square root, and we're looking for the speed, right? Plus 4.45. And then we're going to subtract 3.49. Okay, so just remember again what we did on Tuesday. We have to isolate the radical. So the first thing that I would probably do is I would get rid of that 3.49 by adding. So if I add 3.49 to both sides of the equation, okay, that's going to give me 18.49 equals 1.69 times the square root of s plus 4.45. All right, now I have my radical a little more isolated, but I still have that 1.69 in there. So since it's being multiplied, I'm going to divide it, because that will cancel it out on the right-hand side. And now look, that radical is completely isolated. Okay, so now when you do this, when I put that in my calculator, I get 10.9408. If I were you, if it goes out further than that, okay, I would suggest that you just leave that value in your calculator. I'm just writing that down because I usually go out 4 places past the decimal. Okay, and now we know that that is equal to s plus 4.45. Okay, so we have finally, oops, that's supposed to be a decimal there. We've finally isolated the radical. So remember, after you isolate that radical, you're going to square both sides. So I'm going to square the left and square the right. And I would definitely use your calculator. And this is going to be 119. And I'm going out 4 places past the decimal. So 7017. And that is now equal to s plus 4.45 because the radical disappeared. All right, I want to get the s value, so I am going to subtract over that 4.45 minus that 4.45. That will make that disappear, and we will have s is equal to 115.2517. Okay, now let's read it. It says determine the value of s. We just did that, but it says to the nearest mile per hour. So this would be your mile per hour. That's like your nearest integer, so to speak. Okay, and well, that 2 is not going to bring that up. So that means our s value is just 115 miles per hour. Don't forget your unit. Okay, so then the last part here. It says any b value, so that's your Buford value, that rounds to 10, receive a Buford number of 10. Okay, so using technology, find an approximate range of wind speeds. So let's just, to the nearest mile per hour, associated with a Buford number of 10. Okay, so let's read that again. So basically what they're telling you is they want you to find a range of wind speeds. So they want you to find values of s. Okay, so we're looking for s. Wind speeds are s. Values of s to the nearest mile per hour, here we go, associated with a Buford number of 10. So in other words, this number here has to round to a 10, okay, because it says to the nearest mile per hour, and it says it can round to 10. So this number here, rounded, would have to be a 10, and we want to know what values here we could put in that would give us that Buford number of 10. Okay, my suggestion to you, we can do this algebraically, we can do this via the calculator. And I think that the calculator is probably your easiest way to go. So what I want you to do is take your calculator and take this and plug that in to your y1. So take a minute, pause me, and plug that into your y1. All right, so that's what you should have. Now, we want to see rounded y values. Okay, so we want rounded y values, b values, right here. These are your b values, aka your y values, because we're using a calculator. This would be y, and this would be x, okay? And they're going to round to 10. So go to your table and look at your table of values. And what you're going to do is you're going to look for y values that are going to round to 10. Okay, so if you click second table, and I'm going to show you a picture in just a second, you're looking for y values that are 10. So you should be looking down the y1 column. You're going to be scrolling down for a little bit. Okay, so let me show you a picture. Okay, so this is what I'm talking about. See, I'm finally starting to see here y values that could possibly be 10 if I round them. And look, I had to scroll all the way down to x values of 54, 55, so on and so on and so on. Okay, so let's start with this. They're saying that the b values can round to 10. So I'm going to just look at this y value right here that corresponds with the x value of 54. 9.43. Now, ask yourself, can that round to 10? Just think numerically. Can 9.43 round to 10? No, it can't, because this 4 has to be 5 or higher to make that a 10. So 54 can't be one of the numbers that would represent a wind speed range, okay, that would give us a b value of 10. So let me go to the next one. Let's look at this one, 9.54. Does that round numerically to 10? And yes, it does, which means 55 miles per hour would be a wind speed that would give us a Beaufort scale of 10. Let's look at this one. Does this round to 10? Yes, it does. So 56 miles per hour would represent a wind speed that would give us a Beaufort scale of 10. This rounds to 10. This rounds to 10. This rounds to 10. Now, let's get here. Does this round to 10? Yes, it does, because that 0 is not going to make that 10 into an 11. So we still, all these values from 56 all the way down to here so far are still good. So let's keep going. Does this round to 10? Yes, it does. Does this round to 10? Yes, it does. Does this round to 10? Yes, it does. Look at this one. This also rounds to 10. Okay, so lastly, I'm sorry, I just had to put these on another in another picture. They wouldn't fit. So let's look at 65. Does this round to 10? No, it doesn't, because that 5 is going to bring that 0 up and make this number 11. And the same thing here, okay? So then if you're looking, all of the x values, in other words, all of the speeds that would correspond with a Beaufort scale of 10 would range from 55, right here, all the way down to 64. Okay, so your answer is going to be 55 miles per hour all the way to 64 miles per hour. Okay, and that would be your answer. Now, in my opinion, I think that's the easiest way to do this question, and I think that's probably, you know, the way that would probably work best for most people. Now, some of you honors kids would maybe think to do this algebraically, which it doesn't say you have to, but if you had to do it algebraically, it would look like this. Okay, so I kind of split it up and I would say, okay, what's the lowest number that would round to 10, which would be 9.5? And then what's the highest number that would round to 10, which would be 10.499? And then from here, you're going to have to start isolating the radical, okay? And so I'm not going to go through the whole thing, but I would add the 3.49 over. I would divide out the 1.69, square both sides to get rid of that radical, and then subtract the 4.45 over. Okay, this is a lot more intense, and what I will actually, again, I would suggest is just doing it the calculator way, but this is totally fine to do it this way. And this was a Regents question, and there were kids that did do it algebraically. Okay, so again, you're finding the lowest value that would round to 10 and the highest value that would round to 10, and then you're going to isolate this radical by first adding the 3.49, dividing the 1.69, and then getting rid of that square root by squaring. Okay?